Hello everyone. So we are continuing with the topical past paper solving series. In today's video, we are going to focus on chapter 3, emphasizing on 3.3 of this chapter. So let's first see what is there in this particular topic. Topic 3.3 talks about the moles and Avogadro constant. The important things that you need to remember or understand over here is about a few formulas and conversions. So this particular topic is mainly numerical based. And you will have to remember all these formulas when you are trying to solve those questions. Before starting to solve the past paper questions, we'll just glance through the important formulas. The first thing that we need to remember is that 1 mole of any substance contains 6.02 into 10 raised to 23 particles. Okay. Then to calculate the number of moles, we can do it in 4 different ways. The first way is when the substance is a solid. If the given substance is a solid and if you're asked to calculate the number of moles, you will use the formula number of moles equal to mass by mR. Okay, so N is equal to M by mR. Then the second method is when the substance is a liquid. When the substance is a liquid, we will be using the formula N is equal to C into V, where C is the concentration and the unit of C will be mole per decimeter cube. And V is the volume. Volume will usually be given in centimeter cube and you will have to convert it into decimeter cube. The method to convert centimeter cube to decimeter cube is to divide it by 1000. Okay, so this is the conversion of volume. And then the third method is when the substance is a gas. When it is a gas, we use the formula number of moles is equal to the given volume by 24. 24 is the standard volume of any gas at room temperature and pressure. Okay. And then there is one more method, that is the final method, wherein we will be using stoichiometric ratio. I'll explain this in detail when we are solving the questions, but understand that in stoichiometric ratio method, we will be using the ratio of moles and ratio of coefficients to find out the number of moles. And then you also need to understand the conversion of concentration. If the concentration will always be given in mole per decimeter cube, but sometimes the concentration will also be given in grams per decimeter cube. If that is the case, we have to convert mole per decimeter cube into grams per decimeter cube by multiplying it with mR. So mole per decimeter cube into mR will give you the concentration in gram per decimeter cube. Then you will have to understand the formulas of percentage yield, percentage composition by mass, and percentage purity. For percentage yield, the formula is actual yield by theoretical yield into 100. For percentage composition by mass, the formula is mass of the element by mR of the compound into 100. And for percentage purity, the formula is mass of the pure sample by mass of the sample into 100. Here, the sample that will be given will be impure. Okay, so these are the formulas that is required. We will see how to solve questions using these formula by doing past paper questions. So let's start with the first past paper, which is paper 4.2 from Feb March 2024. The first question over here is to calculate the percentage by mass of iron in iron 3 oxide, that is Fe2O3. We have already seen the equation for percentage by mass. The equation is percentage composition by mass is equal to mass of the element by mR of the compound into 100. So we will be using the same percentage by mass is equal to mass of the element by mR of the compound into 100. So over here, the element that we are focusing is iron because the question says to calculate the percentage by mass of iron. So we have to find out for iron. So this element is going to be iron. And the compound is this whole compound, which is Fe2O3. So if you see this compound Fe2O3, this compound has 2 atoms of iron in it. So the mass of iron will be 2 times the AR of iron. That is the atomic mass of iron. And MR of this compound will be, MR of Fe2O3 would be 2 times AR of Fe plus 3 times AR of oxygen. We are multiplying AR of iron, that is atomic mass of iron, with 2 because there are two atoms of iron, and oxygen is multiplied by 3 because there is 3 atoms of oxygen in the given compound. So if you try to find out the AR, we'll have to look at the periodic table. If we look at the periodic table, we can see that iron is over here, and there are 2 numerical values for iron, which is 26 and 56. If you look at the key that is given to the periodic tables, we can understand that the top value is atomic number and the bottom value is atomic mass. Since we are focusing on atomic mass, we have to take the bottom value, which is 56. And for oxygen, the value is 60. So by substituting the AR of iron and AR of oxygen in this equation, we get the equation as 2 times 56 by 2 times 56 plus 3 times 16. Now, when we are solving this, it will become 112 by 160 into 100, which will be equal to 70. So the percentage of iron that is present in this given compound is 70%. Write at least one decimal place for your answers. Okay. The next question is a typical stoichiometric based question. Let's first read through the question to understand what the question actually asks us. So the question says, dilute nitric acid, HNO3, reacts with aqueous calcium hydroxide, CaOH twice as shown. So the equation is shown, which says 2HNO3 aqueous plus CaCO3 aqueous gives CaNO3 aqueous plus H2O. This is the equation. So if you see the state symbols, aqueous means this is a liquid. Similarly, over here also it is aqueous, which means that CaOH twice is a liquid, that is calcium hydroxide is a liquid. Similarly, CaNO3, calcium nitrate, is also aqueous, which means it is also in liquid state. And water is already in liquid state. Okay, so in this particular question, all the reactant and products are in aqueous state. Now, if we try to read the remaining part of the question, we can see that they are saying 20 centimeter cube of 0.015 mole per decimeter cube of calcium hydroxide reacted with 25 centimeter cube of HNO3 aqueous. So here, from the centimeter cube, we can say that the quantity that 20 represents is nothing but volume. Okay, whenever a quantity is given in centimeter cube, it is volume. It can be volume of a liquid or volume of a gas. Since this reagent, that is calcium hydroxide, is already in liquid state, this is going to be the volume of a liquid. And this particular quantity has a unit of mole per decimeter cube. Any quantity that has a unit of mole per decimeter cube is nothing but concentration. So 0.0150 represents concentration of calcium hydroxide. And then it says it reacts with 25 centimeter. Again, since the quantity has unit of centimeter cube, we need to understand that the quantity being mentioned is volume. But here the volume of HNO3 is being mentioned. So what are the given details in this question? The given details are volume of calcium hydroxide, which is 20 centimeter cube, then volume of calcium hydroxide, which is 0.015 mole per decimeter cube, and finally, they have also given volume of HNO3, which is 25 centimeter cube. And then they are asking us to calculate the concentration of HNO3 in gram per decimeter cube using the following step. The first step asks us to calculate the number of moles of calcium hydroxide aqueous used. So since this is a liquid, we know that the formula to calculate number of moles of a liquid is N is equal to C into V, where C is the concentration given in mole per decimeter cube, and V is the volume, which should be in decimeter cube. So C, it is already given in the question, the value, it is 0.015. So we are substituting that into volume of calcium hydroxide is 20 centimeter cube. Centimeter cube should be converted into decimeter cube. Always volume should be in decimeter cube. In equation, N is equal to C into V. So we have to convert volume into decimeter cube by dividing it with 1000. So when we try to do that, we get the answer as 0.0003, which is nothing but 3 into 10 raised to minus 4. So the number of moles of calcium hydroxide present is 3 into 10 raised to minus 4. Now, to determine the number of moles of HNO3 aqueous which reacted with calcium hydroxide, we have to use the stoichiometric ratio, because if we try using the formula for liquids, N is equal to C into V, if we try using this formula, we know the volume of HNO3, which is 25 centimeter cube, but the number of moles is unknown. Similarly, the concentration is also unknown. So when there are two unknowns in the given equation, we can't solve it with one equation. We at least require two equations, right? So this equation can't be used because we don't know the concentration to calculate the number of moles. So we will be using the stoichiometric ratio method. According to the stoichiometric ratio method, what we will be doing is we are taking the ratio between the moles and the coefficients. So we have already calculated the moles of calcium hydroxide, right? So this is a known solution, and we are referring this reagent or compound to calculate the number of moles of HNO3. Okay, so the moles of calcium hydroxide is known to us, which is 3 into 10 raised to minus 4. But we don't know the moles of HNO3, so let's keep it as X. Let's construct a table for a better understanding. And then, what about the coefficients? Coefficient is nothing but the number that is given in front of these substance in the equation. So over here, if you see HNO3, it has 2 as its coefficient, and for COH twice, it is 1. Okay, so now we have written the moles and the coefficients of the reference element, that is the element whose moles as well as coefficient is known to us, to the unknown element, that is the element whose number of moles we have to calculate. Now what we do is we just cross multiply it and find out X. So this will be 3 into 10 raised to minus 4 into 2. We are cross multiplying, so the value over here is 2. So 2 into 3 into 10 raised to minus 4 should be equal to 1 into X. We are cross multiplying. So X will be nothing but 3 into 10 raised to minus 4 times 2 will be X, or that value is going to be 6 times 10 raised to minus 4. So this is the number of moles of HNO3 that is present. Now, to calculate the concentration in moles per decimeter cube, we use the formula that we already studied, which is N is equal to C into V. Because HNO3 is a liquid and we know the number of moles and volume, so it will be very easy to find concentration by rearranging the equation. So C will be equal to N by V. We know the number of moles of HNO3 as well as the volume of HNO3. So we'll just substitute that and find out the answer. The number of moles, we found it as 6 into 10 raised to minus 4. So 6 into 10 raised to minus 4 divided by the volume of HNO3 used is already given to us. It is 25 centimeter cube. So it is 25 centimeter cube, and this is in moles. Number of moles is in moles. This volume should be converted to decimeter by dividing it with 1000. Okay, so when we try to solve this, this becomes 6 into 10 raised to minus 4 divided by 25 into 10 raised to minus 3. Now, if we use the scientific calculator, 6 divided by 25 is 0.24 times this and this will cancel out and it will become minus 1 into 10 raised to minus 1. So this can be written as 2.4 into 10 raised to minus 2, or the volume, or the concentration is 2.4 into 10 raised to minus 2. The last step of this question is to calculate the concentration of HNO3 in gram per decimeter cube. We have already seen the conversion of concentration from mole per decimeter cube to gram per decimeter cube. What we do is we just multiply the value in mole per decimeter cube with MR of the substance. Okay, so the conversion is mole per decimeter cube into MR will give you the value in gram per decimeter cube. So first we need to find the MR in order to do the conversion. So MR of HNO3 is going to be 1 into AR of hydrogen plus 1 into AR of nitrogen plus 3 into AR of oxygen. So if we look at the periodic table, for hydrogen, the atomic mass is 1. For nitrogen, the atomic mass is 14. And for oxygen, it is 16. So we'll substitute those. So 1 into 1 plus 1 into 14 plus 1 into 16. This will equate to 63. And once we know the MR, we just have to multiply it with the concentration in moles per decimeter cube. We already got the concentration in moles per decimeter cube in our previous question, and it was 2.4 into 10 raised to minus 2. So 2.4 into 10 raised to minus 2 times 63 will give the volume in gram per decimeter cube. So if we try to use the scientific calculator, 2.4 into 63 will give you the answer as 151.2. 151.2, that into 10 raised to minus 2. Or this can be written as 1.512. The answer is 1.512. So I hope this is clear. We have solved all the stoichiometric related questions from Feb March 2024. If you have any doubts, you can put it in the comments. I'll try to respond to it as soon as possible. I hope this video was helpful, and these are very important type of numericals as far as your IGCSE exams are concerned. Thank you.